Assalamu alaikum, grade 9s. This is Mr. Bain. I hope that you guys are all doing well and staying safe. We all miss you very much. And we hope that these lessons are beneficial to you. So today we are going to do 5.3, which is adding and subtracting polynomials. And basically what we're going to be doing is taking everything we learned in 5.1 and 5.2 and combining it into this one topic. So it's kind of like level 5.1 was level 1, just talking about what is a polynomial, what is a term, what is a degree. 5.2 was combining like terms, and now we're going to go to the third level or the third step, which is adding and subtracting whole polynomials. So working example number 1 is about adding polynomials. And I'm just going to make a note here on the side because adding polynomials is basically the same as combining like terms. So they mean the same thing. So if you can remember that, that will be really helpful to you. So the first question says add 3x plus 4 and 2x plus 5. The word and means that we're adding them together. So we have these two polynomials, a binomial and another binomial. They're binomials because they have two terms in them. And we're going to take those two binomials and add them together. So method 1 asks us to use a model. And whenever it says use a model, that just basically means use algebra tiles. So what we're going to do is we're first going to draw out each of the binomials that we have so we can add them together. So 3x minus 4. So that means we have 3 positive x tiles. We're going to fill them in because they're positive. So 3 x tiles. And then negative 4. So it's minus 4. But we mentioned before that you basically just take the sign in front of the number, in front of the term as what it is. So we have minus 4, so negative 4. And then for our second term, we have 2x, so 2 x's, and they're positive, so we're filling them in. And then plus 5, so 5 positive 1 tiles. 1, 2, 3, 4, 5. Okay, so step 2 says arrange the model so the like tiles are together. So I'm actually going to redraw this down here where I'm going to draw all the x's together, where this one and this one, I'm going to draw them beside each other, and all the ones together beside each other. So I'm going to put the like terms beside each other. So we had 3 positive x's here in the purple equation. And then we had 2 positive x's in the blue equation. And then we had 4 negative 1 tiles in the purple equation. And 1, 2, 3, 4, 5 positive 1 tiles in the blue equation. So then that was step 1, draw the algebra tiles. Step 2, arrange the model so that the like tiles are together. Step 3 says circle the 0 pairs. 0 pairs, if we want to remind ourselves what a 0 pair is, when you have 1 positive and 1 negative of the same type, that equals to a 0 pair. Okay, so in our x's first, right here, are there any 0 pairs? Well, no, because they're all positive, so there are no negatives to cancel out. So there are no 0 pairs here. But if we look at our 1 tiles, are there 0 pairs? Well, yeah, we have 4 negatives and 4 positives that can cancel them out. So we are going to circle the 0 pairs, which are these ones right here, and cancel them out, which leaves us with just 1 positive 1 tile. So it says remove the 0 pairs and then draw the model in simplest form. So I'm going to redraw this model as 1 after I've taken out the 0 pairs. So I have 1, 2, 3, 4, 5 x's, because remember I couldn't cancel any of them out, so they all stayed. And then all I'm left with for my 1 tiles is just 1 positive. So if I had to write the expression, I have 1, 2, 3, 4, 5. So 5x, and then I have 1 positive 1 tile. So 5x plus 1. So therefore, 3x minus 4 plus 2x plus 5 equals 5x plus 1. And that's our final answer when we add them together. So that's method 1, okay, using algebra tiles. And it's really easy to visualize with algebra tiles the 0 pairs that you have. Method 2 is using symbols, okay? So we are going to write down the steps on the side so that you guys can do it on your own. So step 1, what we're going to do is we're going to rewrite the expressions without the brackets. So we want to just get rid of our brackets. The reason why we can do this is because we have a plus sign right here. Okay, so because this is plus, we can just get rid of our brackets really easily without it affecting anything. This isn't going to be the same when we do subtraction. Okay, we can only do this with addition. So we're going to just rewrite the equation without the expression, without the brackets. So 3x minus 4 plus 2x plus 5. Okay, so that was step 1. Step 2 is going to be group the like terms. So I like to draw different shapes around the different like terms. If you have different colored pens, this is where it would be nice to use different colors to group different like terms. So 3x is the same like term as positive 2x. Remember, guys, when you're grouping them, keep the sign in front of it as part of the term. Okay, it will really, really help you out. And then the other type of term we have, I'm going to do squares. Negative 4 and positive 5 are both constants, so they are actually like terms with each other. So step 1, we did. Step 2, we did. Now, step 3 is going to be combine the like terms. So this is why I mentioned that basically adding polynomials is the same thing as just combining like terms. Okay, that's all we are doing. So step 3 is combine the like terms. So let's do our x's first. I have 3x plus 2x. This gives me 5x's right here. And then if I do my other terms that are like terms with each other, which are the constants, I have negative 4 plus 5, and that gives me positive 1. And then if I put these together, the answer is 5x plus 1. And that is the same answer we got right here in method 1. Okay, they're just different method, same question, same answer. So again, guys, with method 1, method 2, you can choose whichever method you like better. However, you do have to know the different algebra tiles, okay? You are expected to be able to draw algebra tiles. You're expected to be able to interpret algebra tiles. So it's important that you know both methods. But to actually solve a multiple choice question, you can use any method that you like. So I'm going to say pause the video here. And please try these or this practice question, or these 2 practice questions. So take a minute, pause the video, and come back when you are done. I'm going to go through these questions in a minute. Okay, so Hopefully you have done the practice. If you have this down, you understand it, you can just skip ahead and make sure your answer is correct. If you didn't get it, just stick around and watch me do the practice. So the question says to add the polynomials and write your answer in simplest form. So we're not dealing with fractions here, but simplest form just means make sure that you combine all the like terms. That's what simplest form means in chapter 5. So it gives us two binomials again, 2a minus 1 plus 6 minus 4a. All right, so we're going to do the first one using algebra tiles. So it says draw algebra tiles for each polynomials. I'm going to combine these two steps and arrange the model so the like tiles are together already. So I have 2a and negative 4a. So I'm going to draw them beside each other here. So I have 1, 2. By the way, guys, any variable represents the x tile. Okay, so if it was 2a squared, I would draw the x squared tiles. It doesn't actually have to be the letter x to use the x tile. So we have 2 positive x tiles and 4 negative x tiles. So negative means that they are not going to be filled in. So 1, 2, 3, 4. And then we have 1 tiles. We have negative 1 and 6. And so 6 is positive. So negative 1 and then 1, 2, 3, 4, 5, and 6. Okay, so I kind of just combine these first two steps together. So I arranged the model so that the like tiles are together, and now I'm going to circle the 0 pairs, the step right here. So for the x tiles, do we have any 0 pairs? Well, yeah, I have 2 positives, which means we can cancel out 2 of the negatives. So these will cancel each other out. And then for the 1 tiles, you always look, when you want to cancel out the tiles, always look at which one you have less of. So I have less negatives and I only have 1 of them. So that means I can only cancel out 1 of the positive tiles. Those cancel each other out. So now to draw the model in simplest form means redraw it with whatever you're left with after you've combined all the like terms. So for the x's, we are left with 2x. And then for the 1 tiles, 1, 2, 3, 4, 5. And they're all positive. 1, 2, 3, 4, and 5. And so the expression would be negative 2x, 1, 2, 3, 4, 5, and positive 5, or plus 5. And that is our final answer for our expression. For part B, it's a little bit of a bigger expression. We have a binomial and a trinomial, but again, we have our steps here. Okay, so I'm going to do method 2 for this one, which is the symbols instead of drawing out the algebra tiles. But you can do algebra tiles if you want. So I'm going to rewrite first without my brackets. So I have 3t squared minus 5t plus t squared plus 2t plus 1. Okay, then I'm going to group my like terms. So I'm going to circle all my t squareds. Remember, when you're grouping them, include the sign before it as part of the term. And then I have my t's. I'm going to put my triangles around them. And then I have my constants, which is just one of them. It's plus 1. So now I'm going to actually group the like terms and combine them. So 3t squared plus t squared. Well, 3t plus another t is 4t squared. Then if I do my t's, I have negative 5t plus 2t. So negative 5 plus 2 leaves us with negative 3t. And then for this one, there's no canceling. There's no zero pairs. There's no other like terms. So we stay with +1. And then for our final answer, all we have to do is combine these three together. So our final answer would be 4t squared minus 3t plus 1. Okay, so that's the practice questions that you should be able to do on your own at this point. Now we're going to move on to working example number 2. So we did adding polynomials. Now we're going to move on to subtracting polynomials. But before we do that, we are actually going to determine opposite polynomials. Okay, so this is important. It's an important step for subtraction. So what is the opposite polynomial for each expression? So if we have 3x, okay, we're going to do two things: use a model or use inspection. Opposite polynomial just means what will cancel it out. Okay, so whatever its opposite is will be its zero pair. Okay, so think zero pairs in this case. So we have 3x. We are going to first use a model. So I'm going to model 3x with my algebra tiles. I have 1, and I'm filling it in because it's positive. 2, filling it in because it's positive. And 3, filling it in because it's positive. So we have 3 positive x tiles. And so we're going to keep adding negative tiles to make it a zero pair. Okay, so I'm going to actually write that here. So add negative tiles, I guess negative x tiles, to make a zero pair. How many do we have to add to make it a zero pair? Well, if there's 3 positives, then that means we have to add 3 negatives to make a zero pair, to make them cancel out. So the opposite of 3x is negative 3x. Okay, and then method 2, guys, is just using inspection. 3x is positive. The opposite of positive is obviously negative. Okay, so the opposite of 3x is negative 3x. For negative 2, it works the same way. Okay, so use a model. If I have a model, I have negative 2 tiles. So to cancel it out, I need to add 2 positive 1 tiles to make a zero pair. Okay, so 1, 2, positive. So therefore the opposite of negative 2 is positive 2 or just 2. And we know that from inspection right away as well. All right, but what if it's not just one term? Like what if it's a binomial? Okay, so we talked about how to find the opposite of a term. How do we find the opposite of a polynomial? Okay, well, it's literally the exact same thing. Okay, but you just have to take it one term at a time. So let's say we have 4x minus 1. Method 1, use a model. Okay, so I'm going to draw it with algebra tiles. So we have 4 x's that are filled in because they're positive. 1, 2, 3, and 4. And then we have negative 1, which is just a 1 square tile. So to find what the opposite is, we need to draw out however many we would need to make a zero pair. So what would cancel out these positive 4? Well, negative 4 x's. And what would cancel out this 1 tile, negative 1 tile? A positive 1 tile. So the opposite of 4x minus 1 is negative 4x plus 1, which is what we have right here. And then for inspection, guys, it just basically means you can look at it, and if it's positive, make it negative. If it's negative, make it positive. So it would be negative 4x plus 1 again. All right, so at this point, I want you guys to pause the video and try out these two questions and see if you guys can just quickly find the opposite of each polynomial. All right, so hopefully you did that quickly. By inspection, you should have found that the opposite of x is negative x or negative 1x. They're the same thing. And the opposite of 5 minus 3x is negative 5 plus 3x. If you're having trouble with these two, you should draw out the algebra tiles and see which ones you would need to add to make 0 pairs. Okay, so that brings us then to our last working example number 3, which is titled Subtract Polynomials. In order to subtract polynomials, you actually needed to know how to do the opposite, because remember, whenever we were doing any kind of subtraction with integers, we would do something called AO, which is add the opposite. That's going to become really important for subtracting polynomials. So with adding polynomials, we always just combined our like terms. With subtracting polynomials, we're going to be doing AO. So the first example says subtract 2x plus 3 from 3x minus 4. And then simplify your answer by combining like terms. So we started off with 3x minus 4, and we are subtracting from it 2x plus 3. So this is our problem. 3x minus 4 minus 2x plus 3. We're going to start off by using a model, and model always just means algebra tiles. So we are going to draw it out. Okay, so we're going to start off with 3x minus 4. I'm going to draw that out in purple. So we have 3 positive x tiles, 1, 2, 3, and then negative 4, 1, 2, 3, 4 negative tiles. And then for our, so from this, we are going to remove, because subtraction basically means remove, we are going to remove 2 x tiles and 3 positive tiles. Okay? This is what the question is asking us. So first, we're going to subtract the x tiles. So I'm just going to actually no. This is Miss Teddabean struggling with technology. There we go. Okay, so we started off with 3 x tiles, and we need to remove two x tiles from here. Can we do that? Well, yeah, we have the 2 x tiles right there. We can take these 2 x tiles and actually remove them. So if we do that, I'm going to just draw. I don't like that. Back to my pens. So we can remove 2 x tiles from our 3x. And if we remove them and erase them, how many x tiles do we have left? Well, just 1, because 3 minus 2 is 1. So that's our first step. Our first step was to look at the x tiles. And then our next step then would be to subtract the 1 tiles. But we have a problem here. What's our problem? Our problem is that we have four negative tiles, and the question is saying that from these 4 negative tiles, we need to subtract out 3 positives. But we don't have any positives to subtract. How can we take away 3 positives if we don't have 3 positives? So there's a little trick that we have to do with this. Since we don't have 3 positives to take away, what math allows us to do is that we can actually make or add in our own positives. So the idea here is that we want to make 0 pairs. Okay, so what we're going to do is we need to subtract out 3 positive tiles, but we don't have them, so we're going to actually make or draw our own 3 positive tiles. Okay, we can do this. We can add them in that even though they don't belong. But there's a catch. You can't just add them in like as if nothing happened. You have to add them in, but if you add in 3 positives, you have to add in 3 negatives to balance it out. Okay, that's what this means right here. Make 0 pairs. I just made a 0 pair right here. Why does this work? Well, because the 3 positives and the 3 negatives cancel each other out. They're 0 pairs. So really, if you add them or you don't add them, your answer is still -4. Right? Without them, this is -4. And if you add them in, your answer is still -4 because they make 0. They cancel out. So what's the point? If it's -4 both ways, what's the point of adding them in? Well, now that we've added them in, we have something that we can use. Because we added in these 0 pairs, we can actually now do the subtraction. We can now remove 3 positive 1 tiles from this thing because it exists. Even though this entire setup still equals -4 because these will cancel each other out, now it's a -4 that we actually can subtract positive 3 from. So that's the whole idea here. It's a little bit of a complicated concept to visualize, so you might need to go back and replay this a couple times to get it. This whole thing still makes -4 because if you had to combine the like terms here, right, if I asked you to combine the like terms, what you would do is you'd say, okay, positive cancels out negative, positive cancels out negative, positive cancels out negative, and then I'm left with -4, right? So adding in these does not make a difference in the answer because originally we had -4. Okay, so you have to, what we're doing is we're making 0 pairs so that we are able to do the subtraction. So that we are able to do the subtraction. Okay, so now we added in the 0 pairs, we can actually remove, do what the question asks. So the question says from -4, remove +3. So now we can subtract out 1, 2, 3 positives. We can remove those 3 positives like the question asks. Okay, so I'm subtracting them out, I'm taking them away, and what are we left with? Just like we did with the x's, we have now tiles left over. Okay, so we're going to combine them to figure out what our final answer is. So our final answer is we have the 1x here. So you can write 1x or just x. I'm just going to write x because that's what we're used to seeing. And then over here we have 1, 2, 3, 4, 5, 6, 7 -1 tiles. So -7. Okay, so our final answer when we do the subtraction of 3x minus 4 minus 2x plus 3 is x minus 7. Okay? The algebra tile method might be kind of confusing, or the model method might be kind of confusing for subtraction. A lot of people really don't like it. So the other method is that you can literally just add the opposite. And a lot of people are going to find this easier. Okay? For this, choose whatever method works for you and whichever method you like better. So for method 2, I'm going to write out the steps on the side, okay, so that we can solve the problems. So step 1 is going to be rewrite the expression using AO, okay? So basically change the sign and write the opposite of the second polynomial. And then step 2, we are going to rewrite without brackets, because once we do AO, we change it to addition, which we saw up there that once we have addition, we can just remove the brackets. So let's do step 1 and step 2 first. So we have 3x minus 4 minus 2x plus 3. So I'm going to actually do AO. I'm going to change the subtraction to addition, and I'm going to add the opposite. So the opposite of 2x is negative 2x. The opposite of plus 3 is minus 3. And then I'm just going to now remove the brackets. So plus negative 2x minus 3. You don't actually need this plus right here. Okay, plus negative 2x is just the same thing as minus 2x, but it's up to you. You can keep it or you can get rid of it. I'll just keep it because it doesn't really matter. So step 1 was change the sign, do AO. Step 2 was rewrite without the brackets. Step 3, we are going to do what we did with addition. So group the like terms and then combine the like terms. Okay, so I'm going to now group the like terms here. I have 3x is with negative 2x. 3x minus 2x, or 3x plus negative 2x. They're the same thing. We're left here with 1x, or just x. And then for this, we have, oops, let's do a different color. For this, we have negative 4 and negative 3. We group them and combine them. Negative 4 minus 3. Whenever you have subtraction, you should be doing AO. So negative 4 plus negative 3 is negative 7. Okay. So then our final answer, when we put them together, is x minus 7, which is the same thing we got up here in method 1. 2 different methods give you the exact same answer. So subtraction is definitely a little bit harder because we have to actually do AO. And basically what we're doing is distributing the negative to all the terms, right? So negative 2x and negative 3. So that's kind of what we're doing here. But if that's confusing to you, just ignore that and just do AO, okay? So what I want you guys to do right now is I want you guys to pause the video, okay? Take a minute or 2 minutes, whatever you need, and do the show you know here. And then I will come back and do it with you guys in a minute. All right, guys, by now you should have tried these problems. So I'm going to quickly go through them with you. So for the first one, it said to draw algebra tiles to simplify the subtraction right here. So we have 2x minus 3. I'm going to draw them over here. So 2 positive x tiles and then -3, so 3 -1 tiles. And then from them, we're going to take away a negative x tile and 2 positive tiles. Now this is a problem because we don't have a negative x tile to take away from the beginning, and we don't have 2 positives to take away from the ones. So we actually have to do what we were doing before, which is making 0 pairs. So I'm going to redraw the first binomial in a way that has 0 pairs that I can actually take away the second binomial from. So I still have 2x, but since I have to take out one negative x, I'm going to draw a negative x. But then if I draw a negative, I have to put in another positive. I have to make it a 0 pair so that these basically mean 0 and they don't count, and we still just have 2x. And then the same thing for the ones. I had 3 -1s, and then so I need to take away 2 positives. And so I'm going to add them in, but if I add in 2 positives, I also have to add in 2 negatives, so that these make a 0 pair, and I still just have -3 tiles. So now, can I do this subtraction? Yeah, I can. I can take away this -1 tile, and I can take away these 2 positive tiles, +1 tiles. So take away a negative x and take away 2 positives. What are we left with as our final answer? Well, 3 positive x's and 5 -1s. So it would be 3x minus 5 is our answer. And then for part B, we're going to do it without algebra tiles. We're going to combine the like terms and just use AO. So because we have subtraction, we're going to add the opposite. And remember our steps over here. Rewrite the expression using AO, change the sign, and write the opposite. And then rewrite without brackets, combine like terms after you group them. So let's rewrite it first. Rewrite the expression first using AO. So this stays, it's like KCF. You keep the first one, you change the negative to positive, or the minus to addition, and then you flip the next one, which is adding the opposite. The opposite of 2x squared, I'm going to get rid of the brackets, is -2x squared. The opposite of -3x is +3x. The opposite of -1 is +1. So now we rewrote it with AO, we got rid of our brackets, and now we're going to group the like terms. So 5x squared and -2x squared, those are like terms with each other. So 5x squared minus 2x squared is 3x squared. Then we have -x and +3x. Those are like terms. So -x plus 3x, that's like saying -1 plus 3, which is +2x. And then our last set of like terms is our constants. So we have +4 and +1. So +4 plus 1 gives us +5. And now we just kind of shove these all together for our final answer. So when we subtract them, our final answer is 3x squared plus 2x plus 5. And that is our answer for part B. All right, guys, and that is it for 5.3. I'm just going to write down the homework for you. So your homework, or your textbook work, I guess, since everything is homework now, your textbook work is page 196 to 199. questions 5, 7, 10, 13 to 16, 18, and then 9, I guess 18 to 24. Okay, so this is your homework or your work for 5.3, and that's it for 5.3. Like I said, I think the only hard part about this is the subtraction, but if you know that adding polynomials is the same as combining like terms, which we talked about right here. Adding polynomials is the same as combining like terms, and then for subtracting polynomials, all you have to do is add the opposite. Sorry, I thought I didn't do a question. For subtracting polynomials, all you have to do is add the opposite. Once you add the opposite and then you have addition, what does that mean? That means you're doing combining like terms again. So that's why it's always the last step, because we always want to get to that point. Okay, so the more practice you do, the better you're going to get at it. Please do these problems to prepare for your chapter test on Friday. And that's it for me. So I hope that helped you guys, and we'll see you guys, and we'll talk soon, inshallah.